In this video, I'm going to graph a couple of quadratic equations written either in vertex or standard form. And the things we want to do here are identify vertices, axes of symmetry, y-intercepts, also domain and range, using what we know about both forms. So I'm going to start over here with letter A. It says, let's graph this f of x. And I noticed that instantly here, this is written in what we call vertex form. Remember that vertex form is this a times a quantity or squared quantity x minus h plus this k value here. So the first thing I want to do before we do anything is identify the values for a, h, and k. These are key values in determining characteristics of this parabola that we're going to sketch. So our a value, looks like our a value out front here is -3. Our h value, now remember this is a negative right here, or a subtraction relationship. So we have minus a -1 that makes this +1 here. So our actual h value is -1. And I notice that this completely lacks a k value out here. So k is 0. So using what we know about vertex form, we know that the vertex must be located at h comma k, which leads us to that the vertex must have values -1 comma 0, just from these h and k values right here. And also because we know that the h value controls horizontal shift and k is vertical shift, this would shift left 1 from the origin and up and down none. So I'm going to go ahead and put this on my graph. And I also want to indicate that because our a value is negative, this opens downward, okay? So because it opens downward, I'm also going to write the label of our vertex here off kind of on the top of this. So the axis of symmetry, well, what do we know about the axis of symmetry? Well, it's got to run through the vertex. So our axis of symmetry is this vertical line that splits our parabola in half. I'm going to go ahead and label it with the x value that it's clearly at, which is -1, but also point out that that had to be x equals h because, well, it runs through the vertex. They have to have the same x values. So sketching in this function here, using the fact that a is negative and that it's 3, we know that it's going to be vertically stretched by a factor of 3. And it opens downward. So I'm going to go down 3 and right 1. Since our parent function usually goes up 1, right 1, the reflection would cause it to go down 1, right 1. But then since it's stretched, it would go down 3, right 1. And because we have symmetry here, we see that it must also be true on the other side that it goes down 3, left 1. So here's our parabola here, and I can just by observation determine that the y-intercept in this particular instance is the point 0 comma -3. So we'll list this up here as well. So 0, -3. So last but not least, we want to discuss domain and range. And my favorite part of all parabolas is that they go left and right forever and ever. Even if they get really, really steep, they still go left and right forever and ever. So we are always going to write all real x values, or I'm just going to write all x values in my video here because my handwriting is rubbish. So as far as range is concerned, though, let's observe that on our graph here, we only, on this graph, hit y values that are 0 or less on the y-axis. Those are the only ones we cover. So I'm going to write that our range here must be y less than or equal to 0, all of those values. So looking at letter G, we have g of x here, letter B, but we have g of x equals x squared plus 2x minus 1. This one here is in, as a matter of fact, in standard form. So just like we identify A, H, and K if it's in vertex, we want to identify A, B, and C. And I'm actually going to write those right over here next to our information section. So we say A, well, I don't notice an A value up front. That just means that since I don't observe it, that there's a 1 there, because 1 times x squared is still x squared. Our B value is 2, and our C value appears to be a -1 here. I'll put a box around these. So what we want to do is identify vertex and axis of symmetry. Now recall what we know about the axis of symmetry if it's in standard form. The AOS, axis of symmetry, must run through the x value -b over 2a. And so since I observe our b and a values here, we'll just go ahead and evaluate for this. We say x equals -b over 2 times a, which in this case our b value is 2. You can see that here, and our a value is 1. So this simplifies out to being a value of -2 over 2, or in other words, -1. So this, we know that instantly, I'm going to go ahead and sketch this on my graph here, that the axis of symmetry passes through the x value -1. We'll sketch that in here. So x equals -1. I'll put a box around that. But also that the vertex has to lie on this line. So we know that since the axis of symmetry is at x equals -1, our vertex has a value -1 comma, well, whatever we get when we plug that into the function. So our next step here is going to be to find, well, what is our function value at that x value there? Which means we'll just take out all of the x's in the initial rule here, and we're going to replace that with a -1. So -1, -1. What I observe is that a -1 squared is +1. 2 times -1 is actually a -2 minus 1. So we get -1, or sorry, a +1 minus 2. So we get 1 minus 2 is -1, minus 1 more is -2. So I'm going to go ahead and fill this in up here, -1, -2. And that's going to be this point right here. Does this open upward or downward? Well, observing that A is positive means it opens upward. And I observe also that it's a 1. It's not going to be vertically stretched at all. So it's going to go up 1, right 1, just as its parent function does. But because it does open upward, I'm going to label it below here, -1, -2. We'll go ahead and label the y-intercept here, and I notice that that's at 0, -1. One thing that I do want to point out about that y-intercept is, remember, if it's in standard form, when you plug in 0 for all your x values, this is the only value that's left in your function. So it does make sense that it's at -1 there, and then we'll sketch in the rest of this function using kind of a good sketch here. We can always plug in extra x values if we need to. But as far as domain is concerned, we have all real x values. And range, we are observing that it is all y values greater than or equal to that one right there, which happened to be at -2. So we say y is greater than or equal to -2. Cheers.